How do you transform an AI from a passive chatbot into an autonomous digital employee? In this lesson, we build AI agents. Welcome back to the AI Vanguard Masterclass, where we transition from theoretical models to practical, secure enterprise integration. In our previous lessons, we explored the foundational architecture of generative models, RAG pipelines, and multimodal sensory processing. We established how an artificial intelligence can read corporate data, see digital environments, and hear auditory commands simultaneously. However, despite these incredible perceptual capabilities, the systems we have discussed thus far share one massive operational limitation. They are entirely reactive. They sit idle, burning computational resources, waiting patiently for a human operator to provide a prompt. If you do not explicitly tell a standard language model exactly what to do step by step, it does absolutely nothing. In this lesson, we break that dependency and explore the defining evolution of modern computing. Autonomous AI agents. An AI agent is not merely a language model. It is a cognitive architecture designed for independent, goal-oriented execution. You do not prompt an agent with a specific task. You assign an agent a broad, overarching corporate objective. For example, you do not ask it to write an email. You ask it to resolve a complex customer dispute. The architecture of an autonomous agent relies on three fundamental pillars: planning, memory, and access to external digital tools. Let us deconstruct the first pillar, planning. When given a high-level objective, the agent must autonomously break it down. It uses the reasoning capabilities of its underlying large language model to create a sequential, multi-step execution strategy. The model analyzes the final goal, determines the necessary prerequisites, and drafts a logical roadmap without any human intervention. The second pillar is memory. A standard chatbot has a limited context window and forgets previous interactions entirely. An agent utilizes short-term memory to track its immediate progress and long-term memory via vector databases for historical context. It remembers what it tried 10 minutes ago, recognizes if that action failed, and autonomously adjusts its strategic approach. The third, and most critical, pillar is tool use. An isolated language model cannot interact with your corporate infrastructure. We must equip the agent with secure APIs, granting it the ability to browse the web, query databases, or execute code. When the agent's plan requires external data, it independently selects the appropriate API tool, writes the query, and extracts the answer. It then feeds that newly acquired information back into its cognitive engine to determine the next logical step in the workflow. This cycle of planning, executing, observing, and course correcting is known mathematically as an iterative reasoning loop. However, the true paradigm shift in enterprise digital transformation occurs when we move beyond single agents to multi-agent frameworks. A complex corporate workflow, like launching a marketing campaign, is rarely executed by a single human employee operating in isolation. It requires a highly coordinated team of specialists, researchers, copywriters, data analysts, and project managers working in tandem. We replicate this exact collaborative structure digitally using advanced multi-agent orchestration frameworks within the enterprise architecture. You deploy a researcher agent to scrape the web for competitor pricing, feeding that data to an analyst agent. The analyst agent processes the data and hands a strategic brief to a copywriter agent, who drafts the final campaign. Overseeing this entire process is a manager agent, responsible for quality control, correcting errors, and ensuring the final output meets standards. These agents converse with each other, debate methodologies, and refine their outputs completely autonomously, operating at computational speeds. The implications for operational efficiency are staggering, fundamentally altering how we structure corporate departments and allocate human capital. human employees transition from being the primary executors of repetitive tasks to becoming the strategic directors of digital workforces. Your role shifts from writing the code or drafting the report to defining the ethical boundaries and strategic objectives for the agents. But deploying these autonomous frameworks requires a rigorous, uncompromising commitment to enterprise cybersecurity and operational risk management. Giving an artificial intelligence the ability to independently execute API commands, read databases, and send emails is inherently dangerous. If an agent hallucinates a malicious command, or if it is manipulated through a prompt injection attack, the damage is instantaneous. Therefore, the architecture must incorporate strict human-in-the-loop verification protocols for any action that affects the external physical or digital world. The agent can draft the email, but a human must click send. The agent can write the code, but a human must deploy it. We enforce these boundaries using the principle of least privilege, which we will explore deeply in the Cybersecurity Masterclass series. You must restrict the agent's API access to the absolute minimum permissions required to achieve its specific corporate objective. Furthermore, you must implement continuous monitoring systems that audit the agent's internal reasoning loop and immediately flag anomalous behavior. We are no longer securing static databases. We are securing dynamic, autonomous cognitive engines operating across our digital infrastructure. To assist your architecture teams in building these secure frameworks, I have published a comprehensive multi-agent technical guide. This documentation details the specific open-source libraries, planning algorithms, and API security protocols required for enterprise deployment. It provides structural blueprints for building supervisor agents, managing iterative reasoning loops, and implementing safe tool use permissions. It also outlines the exact cost-benefit frameworks needed to measure the return on investment of deploying an autonomous digital workforce. You can access this critical technical documentation immediately in the professional GitHub repository linked directly in the video description below. Review these orchestration diagrams with your software engineering leads to ensure your organization is prepared for this operational shift. The transition from passive software to active, autonomous agents is not a future projection. It is a present architectural reality. The enterprises that master agentic workflows will achieve a level of operational scaling that is mathematically impossible for traditional human teams. They will execute complex market research, financial modeling, and code generation simultaneously, continuously, and without operational fatigue. However, those who attempt to deploy these systems without understanding the underlying RAG and multimodal architectures will inevitably fail. You cannot build a reliable autonomous agent on top of a foundational model that hallucinates or lacks contextual awareness. The vanguard must master the foundation before architecting the autonomy, ensuring every deployment is secure, scalable, and strategically aligned. In our next lesson, we will examine the enterprise integration strategies required to deploy these agents at global scale. We will move from the laboratory environment into production, addressing cloud computing costs, modular design, and legacy system compatibility. Prepare your infrastructure for the integration phase, where theory meets the rigorous demands of real-world corporate execution. Build the architecture, govern the autonomy, and command the future of your enterprise's digital operational capabilities. Subscribe to the masterclass, download the comprehensive multi-agent GitHub guide below, and join the vanguard. Thank you for your time.